A-level maths students answered this exam question very poorly. The most common mark was only 3 out of a total of 8. Almost 1 in every 4 students achieved that score. Only the very best students were able to score close to full marks. Would you be amongst them? Let's find out. The figure shows a sketch of the curve with this equation, x equals, and then we have a function of y. Part A, find dx by dy, giving your answer as a fully simplified fraction for 4 marks. So we're starting with x equals here, and we've got a function of y. We need to differentiate that with respect to y to find dx by dy. We can call the item on the numerator f and the item on the denominator g. So we can apply the quotient rule for dx by dy. Be careful, don't accidentally write down dy by dx there, because we're differentiating x with respect to y. This is dx by dy. So we can look up this quotient rule in the formula book, if you don't know it off by heart already. It says take the item on the bottom of the fraction, 3y minus 6, and multiply that by the differential of the numerator, 4y. Then we subtract the numerator multiplied by the differential of the denominator, which is 3. And then we divide that by the denominator, but squared. Don't lose that square there. If you get that far, you get your first couple of marks. Next, we can expand the brackets, making sure that we're careful to apply this minus sign to both the 6y squared and the 18 so that both become negative. Watch out for this one in particular. Notice that we can actually factorize 3y minus 6. They have a 3 in common. So notice that I've got nested brackets here. This square is going to apply both to the 3 and to the y minus 1 bracket. So on the bottom of the fraction we'll have 3 squared and y minus 1 squared as well. Both get the square. Notice we can simplify the numerator, combining these like terms here to get 6y squared. We can simplify this further. Remember, we were looking for a fully simplified fraction. Notice that we can factorize the numerator by taking out a factor of 6. That 6 can cancel with the 9 because they're both in the 3 times table. 3 times 2 gives you 6, 3 times 3 gives you 9. Notice also that we can factorize this quadratic term here to give us y minus 3 and y plus 1. That's a good thing to do just to check that it doesn't cancel with this term here. If you get to an equivalent simplified fraction to this, you end up with the final mark. So we were given a sketch of this curve with this equation, and you can see that we have some tangents at 2 points, P and Q, on the curve, as you can see here. And the tangents are parallel to the x-axis. Think about what that means about their equation. They're going to be something like x equals a number. Maybe it's like minus 3 for this one, and plus 2 for this one, for example. I'm just making those numbers up, but it's just going to be x equals some real number for each of those. We're asked in part B to use our answer to part A to find the equations of these two tangents. In part A, we worked out what dx by dy was. At P and at Q, we see that we have vertical tangents. That means that the gradient is essentially infinite at those 2 points. What tells us about the gradient of a tangent? Well, that's dy by dx. So I'm essentially saying that dy by dx would equal infinity, would be tending towards infinity. When would that happen? Well, for dy by dx, that would happen when the denominator, this part, would equal 0. But that's the numerator of dx by dy. So at P and at Q, dy by dx is undefined, but dx by dy would be 0. So that when I flip it over, really I'd be doing 1 divided by 0, which is impossible, right? That is undefined for dy by dx. So essentially I'm setting this equal to 0. That's dx by dy, or you could set the denominator of dy by dx equal to 0 to get the same thing here. Notice that we end up with this equals 0, and therefore either this is 0, so y is 3, or this is 0, y is minus 1. But those are the y values of P and Q. We were asked for the equations of the two tangents, the tangent at P and the tangent at Q. They're going to be in the form of x equals. So I don't need the y values, I need their corresponding x values. How can I work that out? Well, we've got this handy equation here that tells us how to get x from y values. So let's start by subbing in y equals 3 into this equation for x. So replacing each of these y's with 3, doing the number crunching, we end up with x equals 4. So that's the equation of this tangent. And when y is minus 1, if we do the same kind of thing, replace the y here with minus 1, be careful to put this in brackets here. If you do the number crunching, we end with x is negative 4 over 3. That would be the equation of this tangent. Why do you think that students struggled with that question in the exam? Do you think that you would get full marks? Let me know in the comments.